In this module, what we're going to do is give you a sample of a PowerPoint presentation that'll be part of most of our modules that we will provide with all of the training that's associated with ITC 737 and G training. Now, with this, it is an opportunity to see a few questions at the end also that sometimes will be incorporated with some of these lessons. But what our intent is to provide an area of training with a PowerPoint presentation followed up by the actual simulation real time for the module that we're discussing. In this case, what we're going to do is provide a PowerPoint presentation that is a typical ILS approach in VFR conditions. With that, what we've got incorporated in this module is the flight management computer is loaded with an ILS approach, and that's not shown how it was loaded, and those are presented in separate modules. The ILS frequencies are set in the nav heads. That is also not shown. Ref speed for a 30-degree flap approach is set, and that is also not shown. And all those will be trained in future modules. We're going to start this on a downwind, and then from the downwind we'll go to a base and then to a final to execute the approach. What you'll also see in this is a configuration sequence for flaps and landing gear and a final flaps to landing. The autopilot in this module is going to be engaged all the way to almost touchdown. We'll use the typical restrictions associated with it all the way down to 50 feet. We can keep an autopilot engaged, and then it must be disengaged when it is non-auto land approach, and in this case it will. In this particular software, the auto flight director system is auto land capable, so that means that when you're doing a single channel autopilot approach, you're going to have an indication which we'll talk about here, and that will be the case during this approach. We're only going to have one autopilot engaged for the approach. And with that display, you'll see in the presentation that once you capture the glide slope and you only have one autopilot engaged on the mode control panel, you'll have a single channel depicted on the primary flight director. And that is a normal indication for this particular software program. Here's a depiction of where we are on the downwind leg for this approach. We'll make an assumption that we're being vectored for the approach by approach control, and you can see on the primary flight director that our FMA indicates what modes are controlling. Our speed is 230 knots on this downwind. We're at 5,000 feet. What has been previously set up is the minimums for what would be a Cat 1 approach, and the airlines have various methods of setting baro settings for various types of approach. This is just generic, and we do have a ref for 30 degrees of landing, the speed that is set. Here is the approach to the runway to 36 right, and here we are in a vector on a downwind. And one of the things that has already been set up is to establish this ILS approach. We've loaded it in the FMC, and part of that information that we have loaded is the ILS for the approach to 36 right. This gives us information on the runway, the frequency, and the inbound course. We also have selected this 30-degree flap speed for approach and final approach and landing. And here are the waypoints and their altitudes that are depicted as part of the approach, what makes up the approach. So anyway, the setup has, in this case here, you've seen what I just described. Now in this depiction here, we are on the downwind, proceeding on the downwind, and the control says descend to 2,000 feet. So with that, what we're going to do in the altitude window, the mode control panel, we're going to dial down to 2,000 feet because the request is to descend to 2,000 feet. But in order to do that, what we must do is engage level change on the mode control panel. So the first action is to set the altitude. The second action is to execute level change. And when we do that, what's going to happen on our primary flight display, we're going to see that we're going to start a descent down to 2,000 feet. And our FMA, again, was very important to understand what you're going to be expecting to see once you make the engagement on the level change. You want to see the power coming back to idle, and now the speed is going to be controlled by the pitch of the aircraft. And another indication, we're going to get a lot more information on these things here when we get a little bit deeper in the modules, especially in the professional side of the course. This altitude arc line here is something very important to get in the habit of constantly noticing when you're in a descent or a climb. That altitude arc is telling us at what point along with our vector here where we're going to reach 2,000 feet at the present vertical speed that we are descending at and the speed that we have set. Now the controller says slow to 210 knots. So what we're going to do is go over to the speed window, the speed knob, and we're going to set 210 knots. Now, I've got a lot of information about an important technique of doing that. When you set a speed, what you want to do is take the knob into your fingers and then set the speed here on the primary flight display above the tape and with the indice. The same as what we should have done with, I should have said to you with the altitude set. We'll always make sure we're on the right knob, but then when we go to set, we'll set over here on the primary flight display. So now we're slowing. And now as we approach an area where the controller is going to turn us to a base leg, and folks, I'd really like to encourage you, bring the nav display, scale it properly, and bring it into your constant attention. This is the best situational awareness tool you have in the aircraft, and that's not going to be the last time you'll hear me make that statement. So the controller tells us turn left to a heading of 090. So we go up to the heading knob, we make sure we're on the right knob, and then we look here is one place that we can see where we set the heading and just turn the knob counterclockwise. We're turning to a heading that is going to take us on a base leg to intercept the localizer, and we're verifying it here. Now the controller tells us on this, as we're turning to this base leg, to slow to 180 knots. So what we're going to do is again go to the speed knob, set the speed in the window, but be looking at it here. Now here's another good reason in this technique to see why you set this here, because I can see these nomenclatures on the speed tape. And that is a min maneuvering for the flaps up. So if I'm going to set a speed below min maneuvering, I have to extend the flaps. And that is what we have already called for or done. We've set the flaps to 1 because we're slowing below the min maneuvering speed for up, but we'll be satisfied min maneuvering speed if we have 1 degree of flap. Now when you're on this base leg, this is the time where it's going to really get busy in this area here. So start to anticipate that you're going to have a turn to intercept the course. And here we are at that speed of 180 knots. Another thing we have that is indications on our primary flight display is that we have these hollow diamonds. This is the localizer diamond. This is the glide slope diamond. So be aware of those because those are going to start to have action associated with it. And one of the more important things when you're in this position on an ILS, when they're here now, we're within 2.5 miles of the localizer, start to think about the next 3 or 4 actions that you're going to have to take on the mode control panel because it's going to get very busy. And we're going to cover those here in the succeeding steps. So know where to look for the localizer and glide slope activity. And that is in this position right here. So now the controller says turn left to a heading of 040 and further clearance is intercept the 36 localizer. You're cleared for the ILS approach to 36 right. So our next step is to return to a heading of 040, and I can set that heading either on the nav display if I can see it, but I'm certainly verifying it as well here. So now we're in a turn. And the other thing that you need to do is to engage the VOR-LOC button on the mode control panel. And when you do that, immediately when you see that this is engaged, look to see that it in fact is a white VOR-LOC arm. That's a very important indication, because that's telling you that once it gets within area of lock on to the localizer, it will automatically lock on. So here in this depiction, we have observed now, as we're still on this intercept, that it started to capture the localizer, and it's already started a bit of a turn here. But I can see and I can anticipate that that's happening when this horizontal diamond for the localizer has become filled with the magenta color. It's no longer hollow. So we see that we have captured the VOR-LOC on the FMA. That's an important indication. And when we have that happen, the next sequence of things is to see that once it is captured, then what I'm going to do is engage the approach button on the mode control panel. And when I do that, we'll see in this next slide that there is a white glide slope armed. And once I engage approach on the mode control panel, I want to note that a glide slope arm will be depicted in the pitch window, which we'll see in the next slide. So at this point, what we've done is we've engaged approach. So when we do that, we want to note that there is a white glide slope arm in the altitude window. That's most important. Now, the other thing I want to bring your attention to, and it's not really all that necessary for this level of training and indication of what we're doing, but I want, especially you professional people, to get in the habit of watching this glide path indicator on the nav display, because this is essentially a secondary means of slope information during the approach. We'll see that a little bit later on as we get to capture the glide slope. So we're now approaching the final approach fix, and as you do that now, once get in the habit of looking at the distance information to the next active waypoint, and in this case here we're 4 miles. So start to have in your mind a plan on how you're going to configure the aircraft at the final approach fix so that it is in a final configuration for landing. Now, there's a number of different ways that you can approach doing that, but when the glide slope becomes a solid dot and starts to move off the top of the case there, that's a good time to really consider lowering the landing gear and going to flaps 15. So in this case here, and that's somewhere maybe around 3 miles, is another area of where you can consider to put the landing gear down and go to flaps 15, because you want to start slowing the aircraft as well toward the ref speed. So what we did is lower the landing gear and set the flaps to 15, and then what we're going to do is set the speed for flaps 15 in the mode control panel and continue on the approach. Now here we're about a mile and a half from the final approach fix, but we're at a higher altitude than what the altitude is crossing the final approach fix. But here's what we've had happen. At this point here, we have captured the glide slope. And when we capture the glide slope, that's a good time to go to a final flap setting and set the ref speed for landing. Now, I also want you to note that, again, what I brought out earlier, we have the glide slope being captured in the middle of the indice on altitude here, and we are pretty much on glide slope here with a glide path, a secondary means of monitoring a glide slope and a glide path to the runway. Here we are crossing the final approach fix, and notice it's at 1,600 feet. So what you're going to do is cross-check that altitude with what your actual altitude is, and that is FMC generated, but and it will be repeated on the nav display, but there'll also be a final approach fix altitude depicted on a aviation chart. At this point, it's a good point to just go ahead and set a missed approach altitude for the approach, and you can go to the mode control panel, the altitude knob, and turn it clockwise and set 3,000 feet. Now the quickest way to determine what that missed approach altitude is to go to the legs page, which will be up, and you can see it on either the captain or the first officer side. You can see what the altitude is for the missed approach, rather than to go stumbling through charts and any other means of being able to find that altitude. And again, just note that right now we're on a glide slope, and we also have a glide path on our nav display. So here we are coming through at the final approach fix. We can look out ahead and we can see the runway, and we see that we have pretty good indication on the VASI and the PAPI for a visual glide slope indication. And note the nav display glide path indicator is also, again, that secondary source. Two different sources of information for the slope to the runway. At 1,000 feet in the Boeing system here, we have, in the software, we have white vertical line on the altitude tape, and what the top of that line is 1,000 feet above airport elevation and runway elevation in general. Okay, so you can see that at this point here, we're 1,000 feet above the runway, and that's about 3 miles out. That's a little bit over 3 miles out. That's an excellent rule of thumb formula too, 3 to 1. The ILS glide slope, and the nav display agree. Again, that's an important check. You can get into a good habit of monitoring that. There's no reason not to. So the amber line on the altitude tape indicates that we're at 500 feet above airport elevation, and it transitions from white to amber at 500 feet. The other thing you'd probably notice at that time too is that the barrel minimums that are set here with this green line, that's also on the altitude tape, and that'll become important for actual instrument approaches. Once you get to minimums, that green minimum line and delta will change to amber, and we are at minimums for that particular type approach. And you can see we're in great position to land here with the PAPI VASIs. And I also want you to notice that I hadn't mentioned it earlier, but here's that single channel. Once we capture the glide slope, this single channel is a reminder here that we don't have the auto land system functioning. This is going to be a manual landing. So you could disengage the autopilot any time prior and fly this approach manually, or you can take it down to a lower altitude as we are here in this presentation. So here we are at 50 feet, excellent position to land. We see that here we are with the glide slope perfectly placed along with the glide path. We're in excellent position to land, and here is where at a very minimum you would have to disengage the autopilot, which we've done. Now here's a few questions that give you a sample of what is going to be incorporated into some of these modules. As you go back and you think about this particular module, what button selection on the mode control panel, the MCP, is used to intercept a localizer on an ILS approach? It's question number one. How do you know you captured the localizer? Does the glide slope capture automatically? If so, what step must be taken to capture that glide slope? At what point should the aircraft be fully configured for landing for a stabilized final approach? Now this is a little bit different format than we'll have in some of the other modules of training, but this is just some generic questioning that you can, in your own mind, answer the question. It was incorporated in this lesson. Be an opportunity to comprehend how some of this information is what you understand. So here are some answers. The answer to the first question is vor loc. Okay, and that being Let me go back on the slide here so we look and see what that was. What button selection on the mode control panel is used to intercept the localizer on an approach? It is the Vorloc. In order to get a lock-on to the localizer, the white arm in the roll window is going to change to a green Vorloc in that roll window on the FMA. FMA is a very important instrument to confirm what's happening and what you are attempting to execute. No, it doesn't capture automatically. You must select approach on the mode control panel. So for the glide slope, it isn't going to capture. You have to take an action on the mode control panel, which is selecting approach, which is right below the Vorloc button, and then it will capture. And lastly, for a good stabilized approach, you should be fully configured at the final approach fix. Landing gear down, final flaps, and on speed for your landing ref. All right, folks, that's the end of this sample lesson on an ILS approach, a visual ILS approach, a simple ILS approach. Obviously, they're a lot more complicated, a lot more detail that will be incorporated in the modules that get into weather conditions and Cat 2, Cat 3 approaches. Any questions you have, please ask and we'll look to answer them for you. Thanks very much for your time and attention looking at these samples as to what you have an opportunity to learn in some of the modules if you join us. Thank you very much.